Happy New Year and welcome to Agribiotech, the first edition for the year 2019. Agribiotech is a program focused on the significance of biotechnology to agricultural development in Nigeria. I am Lara Afolayo. On the last episode of the program, we saw a public presentation on the BT cowpea to the National Biosafety Management Agency. This was to allow for improved public awareness on the science behind the pot borer-resistant BT cowpea, which is the first genetically modified food crop awaiting commercial release in Nigeria. On today's episode of the program, we shall be bringing you more details on the strengths of the BT cowpea over the conventional variety. But now we bring you trending developments in the agricultural biotechnology space around the world. The African Agricultural Technology Foundation, AATF, is concerned about inadequate knowledge of genetic modification for agriculture by farmers in Africa's sub-regions. The foundation's regional director, Dr. Isufu Abdurrahman Kolo, says African farmers, particularly those in the sub-regions, are yet to apprehend the scientifically developed technology which could go a long way to boost agriculture in areas of livestock production, animal feeds and food crops. The AATF, a non-profit organization based in Nairobi, Kenya, is designed to facilitate and promote public-private partnerships for access and delivery of appropriate agricultural technologies for use by resource-poor smallholder farmers in sub-Saharan Africa. Agricultural scientists say Africa cannot afford to be left behind as the gene revolution transforms modern farming. Director of Partnership and Linkages at the Agricultural Research Council of Nigeria, Yarama Ndrupaya, says this is especially true for Nigeria, which must feed its rapidly growing population. Ndrupaya says some African nations appear to be foot-dragging or undecided about embracing the innovation of biotechnology. He says this approach effectively limited their participation in the industrial and green revolutions that swept the world and the technology revolution that is now underway. The scientist laments that countries like Nigeria have always joined the revolution train late. He says when the green revolution came, Nigeria was left out. He adds that the gene revolution is here and may soon leave countries that are reluctant to adopt it behind. A leading Indian biologist, Nina Ferof, says it is time India gives farmers access to biotechnology crops. The scientist says there is currently a moratorium on the release of GM crops and many in the system are awaiting approval. She adds that it is time that the Indian government completes testing of many genetically modified crops in the pipeline and releases them to farmers. Ferof says there is no evidence that the biotechnology crops widely grown today are dangerous when consumed, either as food or animal feed. Many crops in India have been cleared by research experts, including transgenic mustard, but their release in the commercial space has been altered due to opposition from some activists. Various sections of farmers have, however, protested this delay in the crop's commercial release. Scientists say the adoption of the BT cowpea variety in Nigeria is expected to improve nutrition and food security for not less than 8 million farmers and their families. This is in addition to enjoying better health, environment and improved incomes. The BT cowpea will impact on the gross domestic product of benefiting agricultural economies even more than the conventional varieties. On InFocus today, we shall be seeing the strengths of this variety over the conventional ones. The Bacillus thuringiensis or BT gene is a common soil bacterium around the world. The BT bacteria and proteins have been used for several years as biological controls for certain insect pests and farming, particularly the organic food sector. The Bacillus thuringiensis bacteria produces specialized proteins, also known as the BT protein, which kills certain types of insects without affecting living organisms. This means it is safe for human and animal consumption. It has been extensively studied with regards to crop safety, with no concern so far identified.
It is in the soil. It is a soil-borne bacteria, very harmless to human and any other organism. The bacteria only attack certain kind of insects. The caterpillars, which bores into the crop, the stem, or the fruits. That's the only group of insects which caterpillars attack. It does not attack any other insect, any other organism. It's very safe, highly safe. So it's only toxic. The bacteria attack only one group of insects, but very safe to human consumption or animal consumption. It is in the soil. It has been used since 1938.
The Bt gene has now been infused into the cowpea plant to fight the Maruca pod borer, an insect pest that affects cowpea plants in countries like Nigeria.
Because on cowpea we have a very serious insects, which is producing us, there is no resistance against these insects, both in cotton, in maize, or in all these insects, these borers, these caterpillars. So in cowpea we said we can also do the same technology, use the same technology to control a nasty insects which has been destroying cowpea in the field, the cowpea pods. That's the Maruca. So we have been successful. We get the genes and we put it in cowpea, and it protects cowpea. Cowpea grows very well, so we call it Bt cowpea.
For 9 years, confined field trials on the Bt cowpea have been conducted by the Institute for Agricultural Research of the Ahmadu Bello University in Zaria.
All the necessary research that is supposed to be conducted is because anything that comes new, people used to, at the first stage, they used to reject it. I can recall when the fertilizer was introduced in this country. I know a community in Nigeria, when the fertilizer was dumped there, the people refused to come. So that fertilizer, it even spoiled the water table in that area. Up to today, I know the community where the water there is not drinkable. It becomes hard. So this technology is new. So we are taking steps to ensure the safety of the food and safety of the feed and also the environment. So all the necessary research or experiment that will be conducted to ensure this kind of safety compliance, we conducted it. We did the non-target organism studies to ensure that this gene has no effect on the non-target organisms. So also we conducted a kind of gene flow study to ensure that there is no, a kind of unintended marriage between the transgenic and non-transgenic. So seed density trial, we conducted it and we got a positive result. So this one is to address the concern of some farmers, also some so-called environmentalists, that they say there is a concern of becoming a super weed if there is an intended marriage between the transgenic and non-transgenic. So we conducted a trial for almost 4 years, consecutive years, uninterrupted. We realized a kind of positive result. That concern that it has no negative impact on the environment in terms of that. So also was non-target organism too.
The results from the trials have shown the Maruca-resistant cowpea is an effective solution for controlling Maruca infestation in cowpea plants across Nigeria.
Outside, the materials were excellent because we realized about 4-fold yield increase, meaning that about 4 times higher in terms of yield compared to the conventional one. So having seen that one from our side, the scientists part, we now give it to farmers to test it. So they tested for almost 2 years, and we are now in the 3rd year of their testing. So this year, we are now trying to compare, to see the kind of level of damage that may be recorded from the conventional materials. 3 entries were given to each farmer, or 6 farmers in each location. So a total of 18 different farmers across the 3 locations, Zaria, Minjibur, and Bakura. So each farmer was given 3 entries. The one which is a proposed varieties to be released, which is transgenic, and the other 2, they are conventional. One of the conventional is the most recently released variety. So we use it as yardstick in terms of yield and also other improved traits.
The Maruca-resistant cowpea has also been evaluated from an environmental safety perspective, including its potential to cause harm to pollinators, including honeybees.
For the food and feed safety testing, it was also been conducted, and we got a very positive result that this gene has no effect in terms of, it has no influence in the, either the quality or the quantity of the proteins in this this cowpea. So it's just like a normal cowpea, and even physically, if you see, there's no difference in terms of the color, the texture, and what have you. There's no difference. The only additional difference is that the gene that is carried, which is Cry1AB, which is fire resistant to this insect. That is the additional advantage this material has over the other conventional materials.
In parts of northern Nigeria where beans farming thrives, farmers are much concerned about losses incurred from the infestation of the maruca on their farms. But scientists say the concern of these farmers will soon be non-existent with the approval for the commercial release of the BT cowpea.
The network for cowpea genetic improvement in Africa, which was the first one, the network for cowpea improvements, we really started saying that maruca is such a big problem. How can we get in our hand the genes to improve cowpea? So ATF just took the lead now, took the group leads to get the genes, and also to organize all the research teams, both in Nigeria, Ghana, and Burkina, to work, because these countries are the one which has biosafety legislations. Many other countries in West Africa didn't have at that time biosafety legislations. So this is why we get into Nigeria took the lead in West Africa.
Promoters of biotechnology in Nigeria say when the BT cowpea is finally approved for commercialization, a seed production system will be put in place to give farmers access to certified seeds. And at this point, we take a quick break. Please stay with us.
Did you know that genetically modified organisms, GMOs, are safe and do not pose any risk, hazard, or danger to human, animal, and the environment? Neither do they cause cancer, infertility, sterility, tumor, or any adversity. There is safe use of GMO drugs like insulin, vaccine, rapid diagnostic test kits for malaria, HIV, hepatitis, and so on. The safety of GMOs is certified by the World Health Organization, WHO, Food and Agricultural Organization, FAO, European Food Safety Authority, EFSA, the National Academies of Science globally, the Royal Society, UK, and over 110 prize Nobel laureates. GMOs are safe, effective, and certified by MBMA in Nigeria.
This message is brought to you by the Nigeria chapter of the Open Forum on Agricultural Biotechnology, OFAB, supported by the National Biotechnology Development Agency, NABDA.
And next, we join the former Director General of the National Biotechnology Development Agency, Bamidele Solomon, as he speaks on the benefit of genetic modification for agriculture and the BT cowpea.
Well, Bacillus thuringiensis is a bacterium which has many beneficiary genes in them. Many of these genes are used, to produce. They produce certain proteins, the cryo, genes. Proteins which are kind of poisonous to many insects, and they help in protecting our plants against pest infestation. It is like a mystery, when you look at the Bacillus thuringiensis, in the sense that there are pluralities of genes in it, so that one protein may be harmful to a particular insect, but not to others. So there is selectivity in terms of that, such that there is the target insect and the non-target ones. So you don't want to destroy the entire, insect population. So when we talk of the BT cowpea, then it means it's a variety of cowpea or beans, as we know it in Nigeria, which has this gene incorporated into its genome, and it's now protected against the Maruca vitrata, which can wreak havoc on the farmer, or at least make the farmer unable to rest because he has to apply repeatedly insecticides. The insecticides, the pesticides as we call them, are meant to destroy the Maruca, but at the same time they are going to bite the farmer in terms of cost, to his pocket, and then also even to his health. The person applying it is exposed also to this particular pesticide that is being used, and too much use of the pesticide can leave a very high level of residue on the harvested seeds, which can make the crop or the seed to be unacceptable in some climes where rigorous testing is usually carried out, like in Europe, the European Union, which has a threshold for how much residue has to be in the seeds. The gene is incorporated into the beans, and then once the caterpillar, it is the caterpillar that is the caterpillar. The insect has a life cycle, the egg, then we go to the caterpillar, which is the larva, and then of course before we go to the other stage and get the adult insect. Now what it does is, the caterpillar is the ferocious form, the stage of the insect, and what it does is, as it bites on the chew, either the leaf or any component of the plant, then this protein that we are talking of will now affect the gut of that caterpillar and therefore kills it. Yeah. The science is that the gene produces a protein which is harmful to the Maruca but is not harmful to the human. Well, their physiology, the physiology of the caterpillar is different from that of the human, and the protein that is produced there, I believe, can maybe digestible to the human, while the caterpillar of the Maruca may not be able to digest it, just like we say that one man's honey is another man's poison. Why the Nigerian public should trust these varieties, because particularly the Nigerian society to trust this is because it is something developed by the Nigerian scientists. The Nigerian scientists are very loyal to their own population, and they will not inflict anything that can cause detrimental effect on the population. More also is that the gene we are talking about, the BT gene that is being used, is being applied now to cowpea, but this is not the first time that particular gene is being used. This the cryo gene that is now being used has been used in other crops. So it is not the first time that it is being used, but it is now being used on cowpea, which is now exactly where we want it. And as you've said, in South Africa, in the United States of America, they have used and consumed products developed by their own scientists because they trust them. And the Nigerians should be able to be the first to even use what their own scientists develop, and they should be proud of it. It's nothing that if we eat, we go to the US, we go to South Africa, we eat their own. Why can't we eat our own? In terms of appearance, there is no appearance, no difference. They look exactly the same. The only difference between the two of them is that one has higher yield, than the other. And the higher yield is due to the fact that the maruca cannot affect those particular ones. Marucas are more devastating on the flower at the flowering stage, or on this already the pod that is already produced, and that's why some people prefer to call them the pod borer. So the PBR, which stands for pod borer resistance, now shows that this the Maruca vitrata pest likes to eat directly either on the flower or on the pod that is already developed. There are two things, or maybe some few things that have been looked at the trial sites. One, we want to see the issue of gene flow, and then, of course, how to mitigate against it. In the case of cowpea, it is a self-pollinating plant, in the sense that the genes do not. It's not open pollination. I think you may understand. In the case of maize or something like guinea corn, they are open pollinated because the wind can easily carry the pollens from one plant to the other. But in the case of beans, it is inside the enclosure of the flower, so it does not really move with the wind. Okay? And also, so gene flow is one thing. Then, of course, when it comes to the main field, they can give what they call the safe distance, between one person planting the BT and the other one, the non-BT. Then, of course, it's also the issue of doing some food tests, okay, in terms of food safety, to be sure when it is consumed either by rats or by model animals, and then doing the full analysis in terms of allergenicity tests and all. There are certain proteins. Once the proteins are detected, those are known to be associated with either allergies or poisoning. And there are databases out there. Maybe the example is some in the University of Nebraska in the US, where they send and check. And once it's not found, then it is not known to be associated with any of the allergies that we know.
Nigeria, it's obvious Nigeria needs it to have population is about 180 million now, and the projection is rapidly moving towards 200 million people. And there's obviously, we can there's no way we can feed that huge population using only the hoe and knife and tractor type of agriculture. We need to bring in technology to increase our yield per hectare, for instance. For us to be able to feed close to 200 million people,
the National Assembly passed the biosafety bill, which brought about the establishment of an agency that is charged with the responsibility of biosafety measures. And the House of Representatives, in its wisdom, is supporting the use of biotech in our agronomic practices. One, because of the fact that it has the potential of increasing our food production, especially against the backdrop of the fact that the government is now working hard to diversify our economy away from oil to agriculture. We need to employ modern technologies by way of biotech. One, to increase production, food production, not only to achieve food security, but also to have excess that we can export.
And that brings us to the end of today's program. Send your emails to agribiotech1@yahoo.com. Send us tweets at agribiotech13 or post comments on the Facebook page Agribiotech on TVC. I am Lara Folayo. See you same time next week.